This lesson goes over solving inequalities in two variables. So far, our study of inequalities has involved inequalities with one variable. For example, 3x is greater than 7. Now we're going to look at inequalities in two variables. But before we do that, let's just review what you do when you have an equation in two variables. So suppose I have 3x plus 4y equals 12. Well, there's lots of solutions because if x is 4 and y is 0, we get a solution because 3 times 4 is 12, 4 times 0 is 0, and 12 plus 0 is 12. Similarly, if x is 0, y would be 3. In order to show all of the solutions, well, I could just plot those 2 points, 0, 3, and 4, 0, 1, 2, 3, 4. And once you have 2 points, you can go ahead and sketch the line that goes through them. Now, the procedure that you've learned in class actually is to put it in slope-intercept form, which I would do by first subtracting 3x from both sides and then dividing everything by 4. 12 divided by 4 is 3. Minus 3 divided by 4, I would just write 3/4. And then the y-intercept is 3, which we already have right here. The slope is negative 3/4, so down 3 and over 4. So that's a quick review of how to deal with an equation in two variables. Now we're going to look at an inequality in two variables. So suppose you had 3x minus 4y is less than or equal to 12. Well, I'm going to start in the same way. I'm going to put this one in slope-intercept form. I went ahead and threw in a negative because that adds a complication that I want to make sure to go over with you. So I'm going to start by subtracting 3x from each side. Then I'm going to divide everything in sight by negative 4, which is going to give me negative 3, and negative 3 divided by negative 4 is going to be positive 3/4 x. And then the reason I went ahead and put a negative is because I wanted to remind you that when you multiply or divide both sides of an inequality by a negative number, you need to reverse the inequality symbol. So for this one, the y-intercept is negative 3, and the slope is up 1, 2, 3, and over 1, 2, 3, 4. So if I go ahead and sketch in this line, I know I don't do a very good job passing through the points, but that line represents all the points where y is actually equal to negative 3 plus 3/4 x. But this inequality says y is equal to or greater than. So to show that y could be greater than, remember y is your vertical, so greater than in this case would be above. So I'm going to go in and shade in everything above the line. And any point in the shaded region should satisfy this inequality. You can check that on your own if you'd like. Okay, now let's look at another example. Very similar, now it's greater than. So I start the same way. I want to put it in slope-intercept form. So I'm going to subtract 3x from both sides. And then, sorry, this is a little messy. And then I'm going to divide everything by negative 4. Remember, when I divide by negative 4, this greater than becomes a less than. 12 divided by negative 4 is negative 3. Negative 3 divided by negative 4 becomes positive 3/4 x. And that's very similar to what I did on the previous example. So here's my y-intercept of negative 3. My slope is up 3 over 1, 2, 3, 4. And then you have to be careful on this one. It says less than. It does not say less than or equal to. So the line itself is where the points would be equal, and I do not want that included in my solution. And the way I represent that is by making my line dashed instead of solid. And in this case, it says y is less than, so less than would correspond to below. So I go ahead and I shade in everything below the line. Okay? So just to summarize, if you have a less than, it's going to be a dashed line, and you're going to shade in below. If it's less than or equal to, it's a solid line, and you're going to shade in below. On the other hand, if it's greater than, or if it's greater than or equal to, you're going to shade in above. And again, it'll be dashed if there's no equal, and above if it's greater than. If it's greater than or equal to, it will be solid and above. All right, it's a pretty quick lesson. On your homework assignment, use graph paper, please, and graph 6x plus 5y is less than -20. On number 2, I realize this is a challenge because this one is only involving x, so my hint on number 2 is think about graphing the line x equals -2, because we've learned how to do that. And then try to turn the graph of the line where x is equal to -2. Try to do some shading to show where x is greater than or equal to -2. Please have that ready for class next time.